to the Rhino viewport here, hold it, you can see that the plane is this one here, and by default, if you hover over it, this is a world XY plane, which is just a Cartesian plane system with origin in the 0, 0, 0. So if you just only input the slider, so now I'll press the space bar, and instead of going to edit like we did with the slider previously, let's say that you want the radius to be from 0 to 50, you just press 0, and you can see that we have a slider option here. And if I double click the period symbol now, I will get the domain, and I press, for instance, 50, and I press enter, and I will have a slider going from 1 to 50. So that is a neat trick that you will save you some time as well. If I just input this now, you can see that I create a circle with a different radius. So for the same slider, I will do it again. Search, going from 0, double period, 50. But this time, I will have another period and add, for instance, a 0. If I add 1 0, I will have 1 decimal precision, 2, 3, depending on what I want. So let's say 50.0. So you can see here, it's just whole numbers. Here I have 1 decimal position. So it does exactly the same thing, just more accurate. And you can change the name of the sliders if you want to keep it consistent, because we're going to have a couple of them later. So if I right click on the name here, you can see on the top here, I can change the name. So I just mark this and type radius. So there's a circle. And as you can see, we can have a problem later when we can only work in the XY plane. So we want to change the input here as well now, just for the training sake. So if you go to vector category here at the top, you can see a plane subcategory. If you go down here, we have 3 global planes. So I will just drag those. We have an XY plane, which is one that you can find by default. You can have an XC plane, so we can just type it, XC, XY. And we'll have a quick look at these before we move on. We'll just hide these for now. And as you can see, for a plane, you have a plane has its own coordinates or vectors. So this is X and Y. So if I use a panel now, you can see world XY, world XC, and world XY. So if we now create a point one more time, and I will just use the shortcuts here, panel, curly brackets, and make it 10, 10, 10, for instance. Press enter. So this is a point. And if I now change the origin of the plane, you can see that I have the plane up here, which is the same that Martin did earlier when you set the C plane. So this is how we do it in Grasshopper. And you can do the same thing for an XY plane. Moving it up here, I can do it for X. Sorry, that was XC. I can do it for the XY plane as well. And just hide the 2 others. Show this. And oh, sorry, that's want the YC plane. So this YC to get the global YC plane. I'm changing the origin to 10, 10, 10. And you see the difference now in the global coordinate system that we have here. The x-axis is marked in red and the y-axis is marked in green. And for this plane now, you can see that the x-axis of the local plane is going in the global y direction, and the y-axis is going in the global z direction. So you can see that here as well for the input. See, there's a question maybe. Oh, change the panel. You can just double click on the panel, and as long as it's an input, and you can change it. And press outside the panel again. So yeah, the axis of the plane. So in red, you will have the local x-axis, and in y, you will have the local, and green, you will have the local y-axis. So you can see now that for the YC plane, you have a normal vector here in the global x direction, 1, 0, 0, which is out of the plane in the normal direction of the plane. So if you try to input these to the circle now, you can see that instead of being in the world XY plane, we can change the plane of the circle, which will come in handy later. So we then have a circle, and now we will try to create a rectangle. So if you again go to curve, primitive, then almost at the bottom left, you will have a rectangle component. And this works very much in the same way as the circle, except that it has two inputs here, a x size and a y size. And for the circle, you just had a number on the radius. If you look at the plane of the rectangle here, you will have something called a domain, which is going from one number to another number. So the default rectangle here, if I zoom in on it, you can again see that the plane will have an origin in 0, 0, 0 by default. And then the x size is -1 to 1. So you can see it's not that hard to see, but this is the outline of the rectangle. And it's starting at -1 and goes to 1. And the y size is from -2 to 2. So if we just I'll just copy this slider here, put a number into our geometry, just make it bigger for you to see. Let's get it outside at normal global plane to see it. So make a slider from 100 to 200. Input that into the x and y size. You can see that the center point of this rectangle is no longer in the global or in the origin of the plane that it's created within. And that is because if you see here at the x-axis again, we've created a domain which is going from 0 to 100 and not from -50 to 50, which is what we actually want. So to change that, we can create our own domain, and you can do that either in a panel. Again, just first quotation mark and say -100 to 100. Just press enter. Then you can just input that here and here, and we have changed the domain. But now it's not parametric, so we'll try to make a parametric one. So if you go to maths, you have a subcategory of domain, and the first one, construct domain. We will have a domain start, a domain end input, and we will just use one slider for the x size. So I'll just name that x size. Then we will have half of this in both directions. So we can use a division component. So just a slash symbol, you can see that's shortcut for division. Input the first number here, which is the x size, and I will just create a panel which divides it by 2. And input both here. And you now see we created a domain from 50 to 50, but we want -50 here. So the easiest thing is just to right click on the domain start. You will have an expression option here. And this is just editing the input. So the x by default is the input parameter. So you can type 2x and it will double whatever comes in here. You can type x minus 1, and you will just subtract 1. So if I do that, you can see it's go from 49 to 50, because the input here will be now 50 minus the 1 that I entered in the expression editor here. So for this topic, we would just want minus x to make it negative. So again, you go to domain start, right click it, the expression button, just type minus x, commit changes, and we will have a domain from minus 50 to 50. So I can then input that to this rectangle here, and you can see it starts in minus 50 to plus 50. So I'll let you do the rest. So you can create a new domain for the y size with an individual slider going from 100 to maybe 500. You should divide it by 2. You should create a domain going from minus half of the input to positive half of the input, and you should input it here to create a rectangle. So I will give you 3 minutes to do that, and we'll continue after that. And if there's any questions while you're doing that, just comment them, and we will answer. Yes, so Simorsin answered your question, yeah. So you can just press Control and you can drag the components again together. So it doesn't matter what way you do it, just one way, just drag them together while you're holding Control. Or you can right click on the input side of the component and you will have a disconnect. There you can select it as well. So I think we'll continue. So I'll just copying this. And we'll change the value of the slider here to 500. Just rename it to y size. And we have a rectangle here. So you can also, again, like for the circle, you can change input plane to see what happens. You can change the point of that, and you can play around with this afterwards if you want to. Yeah, question from SBS that Simorsin is answering it, but yeah, for your division here, if you don't have both inputs, it will just be orange. So you need to create a panel, for instance. Again, quotation mark, and I just type 2, press enter. Oh. And just drag it into there. So in general, if your component is orange, you will see a small balloon symbol here, and you can press that and you will get an error message telling you what is wrong. So that can be a nice way of finding your problem if you don't know what you've done wrong. And right now we're getting a couple of components. So say that you're getting lost somewhere here. You can do like you did in Rhino. We will have like a navigation file here. So if I want to go left, I can just press a small drop down here. I can go right, and I can change my view settings. And if you're entirely lost, you have always the option to go left, and you will find it. And you can, of course, zoom the one you want by zoom selected, which will focus on the one that is marked. So I think we have our rectangles, we have our circles, we have looked at some different planes. Just a question from SBS here. It's red. Can you press the red button or the red balloon message to see what it says? I think I'll put Marcin on the case and we'll continue. So we have a circle, we have a rectangle, which are both closed curves. So now we want to make surfaces. So SPS, instead of, if the panel is not working, you can just use a number. So just type 2, for instance. You can use that to work as well. So the circles and the rectangles, I'll just shift them over here so that you can see. Yeah. Oh yeah, sorry. Okay. The problem with the text, I have Marcin on the side here. So when you type something, by default, it is a string, which we will go through when we start on the C#, which is character parameters. So when you press 2 into Rhino, or the panel here, the division component is able to extract the number and make it an integer or a double, depending on what you input. But if you also place other characters, it could be a number, a letter, or a space. It will read it as a text file. It's working for me. So. Are you using Rhino 5, by the way? SBS with the problem? You can just write it in the chat. But in general, if you use strings, which is just characters, it won't be able to read that. So if I write 5 as a text, for instance, it will not work, and you can't change that to a number. So yeah, back to the circles. We want to make surfaces now. So we're going to use the same method that Marcin used. So we have a boundary here, which is a closed curve. So we go to freeform subcategory of the surfaces, and we have a boundary surface component, which you can drag onto the canvas. So this will make a surface within your boundary curves. So you can place a circle here, and you can see that we get our small circle there, which is a surface. And you can get a rectangle here, something inside of this boundary. And for the rectangle, you have a final input that could be nice if you want to create some fillet edges, which is the radius. So just create a new slider going from 0 to 40 maybe. And this will trim the curves of the rectangle. So for instance, maybe you want to make a hollow section. with the radius on the edges, you can use this component. So we have surfaces, and of course you can make surfaces in other ways. You can make them from corner points. You can make them from a series of points. You can make edge surfaces. You can make a loft. So we'll try a couple of these now. We'll just disconnect this. Again, hold Control when you drag it, and you will disconnect it. So I will just remove the fillet here. And this is, as it now is a one solid continuous curve, I will explode this to subtract each straight curve from the rectangle. So just type explode, and you will have a component which will divide this rectangle into different segments. As you can see now, if I change to a panel, you can see I have 4 line-like curves, which are these 4 edges, whereas before I did it, it was just one rectangle curve. So from this, I will use something called a list item, and this is just an introduction, so you will go through lists and trees tomorrow with Marcin, but we can use it now and we'll have a look at what they're actually doing later. So this list item component allows you to get specific items from a list like this. So let's just keep one here. I input the segments, which is the lines. The other output here is just points. If I can show you here, it will be those vertex points. So the segments go into the list item component, and I have 4 items, and we start counting from 0. So if I type 0 here, 2 periods to 3, create a slider going from 0 to 3 with whole numbers, and I can input that to the index, and the index is the index of the item that we want to output. So right now you can see I can hide these so that you won't see. So you can just see the one line here, which is the first item in this list. And if I change this to 1, I will get the second item, I will get the third item, and the fourth item. And I can know also, if you zoom into the component, you will see some plus signs here. I can press on those, and I can get, obviously, I get 4 items here. So I will remove the slider. I will just extend it like this, +1, +2, +3. So, and each of these output will now contain just one element from the list. As you can see if I hover over them. And you can also go the wrong direction. So you're starting at 0, which is the first element of the list. And you can go backwards. So -1 will get the final element of the list. -2 will get the second final, and so forth. So we will go in the right direction now. And the loft, as Marcin showed you, takes 2 curves or several, which it will create a surface between. So for now, just take the first one and input it here, and the second one, which will be our third one, which will be here. Hold Shift, drag it, and you will get something like this. And the reason for this is the direction of the curves. This curve is going in this direction. This is going in that. So have a flip curve component connecting this, and this should work. So this is a little bit tricky if you're not familiar with Grasshopper. So I think we will just leave it there. And for now, we will just use this boundary surface, which is making everything a lot easier for you. So let's stay with the rectangle. And we'll show you one more cool thing that you can do with the boundary. So now we have just one boundary curve, which makes it solid. So let's try to make a hollow section, like a column or a beam. So if you just mark everything here, creating your rectangle, copy it, move it down a little bit, and you can delete the input of the X and Y size here. And then we want to make a curve inside the first curve with just an offset. So for instance, we need a negative subtraction component. So just press a minus sign and you will get that. Take, for instance, start with the X size. Put that as a first input, and we will create a slider going from 20 to 50. As a second input, I will change the name to X offset. I will input that here. And we will do the same thing for the other direction. So just Control-C, Control-V, copy it. Input here, rename it Y offset. Drag the Y size to it like this, and you can see we have the first number minus the offset, which should be our domains now. If I display this, you can see that we have a rectangle within the first rectangle. So if I now input this one as well to the boundary surface component by holding Shift, dragging it to the input, you can see that it creates a surface between both the boundary curves. You can change the offset here. We can also create a radius. Once again, a slider. Input that to both the rectangles. And you will have something like this. So that's surfaces, and I think I'll just do the brep or the solid objects real quick before we take a 50-minute break. So from the surface, I now want to create some kind of beam going in the global Y direction, or X direction, sorry, the red direction here. So exactly the same as we did in Rhino, we are going to extrude it. So we have surface here, subcategory freeform, and you will find an extrude component, which again, exactly like in Rhino, we have a base surface, which is a cross section for a component, input that as a base, and the other input is just a directional vector. So a vector, a Cartesian vector. So again, instead of creating a vector, which can be created, for instance, exactly the same as points, you can create 1, 0, 0, which would be a unit vector in the X direction, 0, 1, 0, Y direction, and so forth. You have just, if you type X, you will get a unit X vector component, which does that for you. So it's a little bit faster, and you can input that. And you now see that we have a brep with a thickness of just 1, which is the default as it's a unit vector. So to make it longer, we again create a slider, say from 200 to 500. Input that to the factor, which is the multiplication factor of the unit vector. Then you have some kind of beam. Real short one now, but you can make it longer, of course. So, are there any other questions to that, or should we take a break? I see that, yeah, I will upload the file on Mural afterwards. So you will get everything from today. Okay, so if there's no questions apart from that, we will meet again at 1:45, and we will start in the building that Martin made earlier, just in a parametric way inside Grasshopper. So I'll see you then.
Okay, guys, one thing, I will just share my screen. You can go to Mural now, because in the day one, in the bottom, you will find the tips from part 2. So you will have most of the things which we were using. So I was trying to follow Sfera and type all the things we used. So if you feel confused or something, also in a second I will make here a component with the or Sfera will add the component with the Grasshopper file in this place. So you will have everything here. So yeah, if you are thinking about day one, then take a look on this column too, and especially the bottom with the Grasshopper. The expression in the domain, I suppose it's this one. Rectangle is using domain to make it use panel apostrophe -200 to 100 to construct domain. I upload the files. They should be available on the Mural webpage. So there should be link to the Google Drive, and you can generally download them. If it's not working, let me know. I will see what it should be working. You should have two folders there. So there should be a Grasshopper files, and then you should have the Grasshopper files from today.
Okay, so I think we'll start again. We covered the very basics of Grasshopper, I think. So we should be ready to start on recreating Martin's building from the first half of the day. So I'll just zoom in here and we will try to do this in Grasshopper. Quick question. The video file seems to be empty. Martin will take a look at that and he will fix it. So we will start on the building. So I just have the numbers here and we will go back to Rhino. So I've uploaded the files now, and if you haven't saved it, you can do that. And I will just delete some things that we don't need. And we will start working on the building. So before we do that, I'll just show you another quick trick that can be useful. So I'll just clean up a little bit here. And here you see we created a domain for the rectangle, and this is kind of algorithm that you will be using a lot. So instead of having to create this the entire time, we can do something called a clustering. So I just create a domain container here and just connect these two to it just to keep it there. And if you now do that, just once again search for domain and you will have the domain without the power of 2 there. It's a 1D domain. Just connect these boxes, mark the 5 components, which creates the domain from half of the input distance, and you right click and you have something called a cluster here. So just press that and you will now create a box which contains all these components. So you can save some space and it's in general very simple to use. And you can also export it if you want to use it for future projects. I'm not going to do that here, but there is in the Q&A OneNote and the Teams, there should be a little note about the cluster that you can read if you're interested. So I'll just change the name again to X size and Y size. And then we have a rectangle. So I'll remove the plane again. Just right click on it, disconnect. I'll also disconnect the surface for now. I just want to show the rectangle, which is here. Don't want a radius either. So this is what I want now. Just a domain, a rectangle, and an X and Y size input. So if we go back to the mural, we had 5 times 8 meters distance between the columns. So maybe we want to create a parametric definition of that for the width of the floor, say from 30 meters. So it should be 3,000 to let's say 50. Just the X size. The Y size, we want 15 meters. So let's say that that should be from 12 meters to 20 meters. Right, so there we have our domain for our columns. And if I now connect the boundary surface again, remove this, we have a base surface, and I don't want to make a division of this to get the points that we will use for the columns. So if you go into surface and the component palette, you have something called utilization here at the right. Select that and divide surface. So drag that into the canvas and you input the surface, and by default you can see here it creates points on the surface. By default it's 10 by 10 the UV count, but we will make sliders, and we have 1, 2, 3, 4, 5, 6, and 4. So let's say from 4 to 10 in the U count, rename it, and let's have 3 to 7 in the V direction, just to make it different. Renaming that to keep a track. That's the U count, that's the V count. And the output here, just show you that, will be what is called a data tree. So you can see we're used to having these straight lines, meaning that it's just an item or a list, but now we have a dotted line. So if I hover over here, you can see, I just simplify it a little bit, it doesn't matter. You can see that there's these curly brackets and an integer, and there's another bracket with the number of items in the list. So this is what's called a data tree, and again you will look at this tomorrow, but it's not about it. So you can look at it as a 2D array or a matrix if you're used to programming. So if I extend this here, you will see that the first item in the or branch is 4 points, 4 points. So each of these columns here of points is the input in a branch. So the U count here is the number of branches, and the V count is the number of elements in each branch. And for those of you who've seen it, it's the U count here, the V count is not consistent. So we have one more output than input, and that's because it starts at 0, so 0, 1, 2, 3, 4. And we just want 3. So we have to go to our expression again just to keep it consistent with the input, which would be the number of columns in each direction. So go to expression again, press X minus 1 here to make sure that the number of input is the same as the output. Again, X minus 1 for both. If you've done it right, you will see this small symbol here. So I will just drag this input sliders over here to keep a track on everything. So those are our column points. I can hide the surface here. So have everybody gotten this far, or are there any questions? Oh yeah, sorry, the default is millimeter in Rhino. Thank you. So just change that to make it consistent with Marcin. That should work. Yeah, centimeters. Okay, thank you. So we have our points. So let's create our columns, and we can use the same code because we want to use rectangles here as well. So I will just copy these two, Control C, Control V. And I will create new sliders. Let's say we want to go from 20 centimeters to 40 centimeters columns. Color dimensions, and for simplicity, I will just use the same dimension in the X and Y direction. So if I show this now, just have a small rectangular column here. So this is where the planes from earlier comes in. So we now have a point. So what I want to do, first of all, we don't care about the data tree for now. So if you right click on these points, you can press what is called flatten, and that will convert this data tree system into just a single list of points, which will be enough for today. So I do that, and you can see that everything is now a single list. So next thing I want to do, I want to keep it in the world XY plane. So just type XY, get the XY plane, and you have these points here. If I input these now into the origin, you will see that I get, or the plane creates a plane with the center point in each of these. So instead of just one element, I have now 12 elements or 12 planes here. So if you hover over the middle of the component here, you can see that it ran 12 times, created one plane in each, in this, with the center in each point. So I can then input this to the rectangle here, which now just have a global world XY plane as input. But if I input this one with 12 planes, we will get a rectangle inside or around each of these points. So I can just make them a little bigger so that you can see. Oh. So this is working now, controlling every column here. So that's our columns. And we now want to create the surface. So again, we can use the rectangle and domain. So just copy that. And just show it. And here we want to use the XY. We want to have almost the same dimension, but as you can see now, the rectangle here is crossing point. So we want to push it to the outside of all the boundary columns so that it doesn't collide. And maybe we want to add the possibility to have some extra offset as well. So I think you know all you need by now to create that. So I will give you 10 minutes. So you should try to make a new domain, which is of this size, plus the size of half of the column width, plus some extra for the offset if you want some cantilevering part of the slab. So I'll give you 5 minutes. I can just sketch it up here. So you can have a column here, something like this. And you need an offset here, which is half the column width. Plus maybe you want something extra, some offset. So I'll give you 10 minutes to try to do that. And in 10 minutes, we will do it together if you haven't managed. So if there's questions again, just post them in the comment and I'll let you work for 10 minutes.
I could paste my contents here. Let me check. Is your number? Yeah, you have. What? Yeah, no.
Okay, so we'll start again. Did anybody make it? You can raise your hand if you made something that are close to the solution at least. There's some hand, that's good. So I'll just quickly go through it with you, but the idea is that we have a width there and we want to add something to it. So you have like the subtraction, you have an addition component, so just press plus. I'll just move quickly now. So we have the x size and we want to add dimension of the column and we want a slider, so I just copy that. So here's the x size plus the column, and then we want another slider for the optional offset, which can go from 0 to 200, for instance. So if you add that one here as well, I'll just copy this and put in the y size and copy this one as well, y offset, input that here, so that you will have the actual size plus the column dimension plus an optional offset here. So if you input that, you can see the rectangle here going with the edges, and I can also add an offset in X and Y direction. So with this, we now have the boundary for both the surface and for all our columns. So just go back to the boundary surface again that we were using earlier. Select that. So for the rectangle, which will be our slab, copy that, input it to here, which will be our surfaces. So we now have for one story, we have the cross section for both the slab and the surfaces. So if we go back to mural now, we want to copy this into a selected number of layers. So just jump back to Rhino. To do that, we have something called a move component. So if you search for move, it will be the bottom one. Again, it takes a geometry and a motion, which is a vector. So if I try for the columns first, you can see that the input will be 12 columns and everybody will move in a direction of 1, 1, and 10 in a global Z direction. So we want to keep it in a Z direction. So I just type a Z to get the unit Z. Input that, but we want the floor height to be parametric. So let's say from 250 to 400. Input that, and you can adjust that. So that's our columns. Just copy these three components, Control C, Control V, and do exactly the same thing for the slab. And we just need, since the height is the same for both, we just need one slider here, which is the floor height. Delete that. And of course, we want more than just one floor. So one option could be to copy everything, input it again, and multiplying this one, then twice the second floor, etc. Instead, we're going to use a series. So search for series, which is this component. See that I forgot bifocals. Sorry about that. Now you should see the name of the components. So the series here, which takes a start input, which is going to be 0, which is the ground level, the step, which is the height of each floor, and the count, which is the number of repetitions. So the outcome of this series component is the list, which takes the input and multiplies it with from 0 to 9. So we can make another slider for the number of floors that we want. So a minimum of 2 to get the roof and a slab floor. And let's say 5 for now. I'll just change the name again. Stories to here. Now you can see we have a parametric number of stories. So I'll just mark these 2 and move them to the left again to have all the input here. And we can input this directly into here. And now we have 12 values here and 4 values here. So as you can see, something is wrong. We have 12 geometries. The first one is moved 0, 0, 0. The second, as you can see, is here on the second floor. The third column is on the third floor, and then the rest of them are moved with the final vector. So in order to make, and what we actually want to do is that we want to move every 12 columns. First, we want to move them with a height of 0, then 400, 800, and then 1200. And to be able to do that, we have to use what is called a graph. And again, this is tree operations, which we will go through with Marcin tomorrow. But for now, we can take it if you right-click it here, select graph. Oh, sorry, we will do the other one. Graph like this, and then you can see that we have everything. So what this will do now is it will take this list, which is one list, and it will first operate on it one time for the first vector, one time for the second, one time for the third. And the output is, as you can see, 4 branches with 3 with elements inside each branch, so that we have one branch for each floor with 12 columns in it. So try this just to show you what's happening. I'll choose explode component, explode a tree. I'll input the tree here. I'll just simplify it. And plus to get all the 4. As you see now, if I make it smaller, if you just have the first one, we will have every column here. Twelve column surfaces on this first floor. The second branch will be here. The third branch, the third floor, and finally the fourth branch. So, but you will go through this later. So just accept it for now, and by Thursday you will be experts in this. So we now have the surfaces, and then we will do exactly the same thing on the slabs. Or so again, just copy this. And instead of this, input this, and you have 3. So the only problem now is that we have, or it's not a problem as of yet, but we can just copy that. And because you want one roof or slab more than number of columns. So here, if we say we have 4 stories, we just want 1, 2, 3 levels of columns. We don't want a row of columns on the roof. So again, we have the count here for the columns. So if you right click on that, press expression, go for x minus 1 again. And if I display that, you will see that there are no columns on top here. So we have the bases. So the next thing to do now is just to extrude it to make our building. So we can start with the slabs. Just extrude component that we used earlier. Select that, input. Now we have 3 surfaces and a direction, which now is going to be negative because we want the top level of the floor to be the level height. So it will extrude it downwards. So just select a C, input that, and then we want the height of the slab, so say from 20 to 40. Name it slab height. Input that. Now it's upwards. We want it downwards. So right click on the factor, use the expression again, and minus X. And OK. So there we have solid slabs, which are these ones. And finally, we want to extrude our columns. So just copy it, input the columns, disconnect this. Now we want it to be upwards, so C again. And the height of the column should be the height of the floor minus the thickness of the slab, because we want, like Marcin used the Boolean operations, we'll just subtract the height of the floor when we select the height. So minus sign for the subtraction. And we have the slab thickness. We have the floor height over here. So floor height minus slab thickness gives us the correct height of the columns. Input that. And as you can see, we now have all the columns as well. Okay, are there any questions, or did anybody make this? If everybody who has made it can just raise their hand. Yeah, that's good. It's a lot of people. So I think we'll give you 5 minutes. Those of you who are finished could play along with it. You can try to change the sliders and just experiment with it. And those of you who hasn't finished can do that. And in 5 minutes, we will start on trying to make these parametric edges there, which Marcin made. We'll try to extend our model a little bit. Just one question. They can explain the input from the series component to the move component again. Let's see. So yeah, the series component here. The move component takes the geometry that it's supposed to move and a vector, which is just the direction to move it. So by default, if you just enter one number here, you will just move it one time. So with the series component, we're creating a list. So it will start from 0, and you can set that as well. I can change that. I can change it from 0 to 400 just to show you. And that will change the starting point of that series. So 251, it will start from 251. The step input is the number of repetitions, or sorry, the difference or the height. So that is for now the floor height, which was 400. And the count is the number of repetitions. So if we just take the first number times, or the height, which is the step, times 0, times 1, times 2, times 3, depending on how many counts you have. And then you will input that list here into the vector, which will give you 3 vectors. So instead of just moving this one time, you will first move with this graph here. You will move it all of these 12 columns nowhere, 0, 0, 0. Then you will make another output which moves them 400 upwards, and then finally we'll move them 800 upwards. So the geometry there would be like this. Just raise your hand if that was clarifying or if I should continue. Great. So yeah, I'll give 4 minutes to 14:30, then I will continue. Okay, so we'll start again. So for the final part now, we have 30 minutes left. So I think we have time to create at least this part of the edge and adjust the surface a little bit to make this side parametric. And I will just upload after the class, I will upload a proposal of how we can make this one parametric as well. So we'll just make this short edge for now with the poly curve. So going back to Rhino. We'll just hide extrusions and we will work just this surface here. So we have a surface here based on the rectangle. So like I showed in the beginning, we will use the explode component here. I will take the rectangle and make 4 line-like curves. And then I will use a list item component to access this curve here. So inputting all the segments to the list here. Again, we have 4 lines, so I'll just create a slider from 0 to 3. Since the indexing is starting at 0, placing it here, highlighting, changing there, I have this edge. So on this edge, I'll just try to draw it for you. We have the edge here. Oh. So what we want to do now is we want to get the line here and create a point along that line somewhere at the distance, which is a parameter, we'll call that P1. And then we want to move that point with the second parameter, P2. And from that, sorry about this. We will create a polyline through there, which is then going to be used to make our surface. Okay. So I have the line. So the first thing that we're going to do is to get a point along that line. So you can use a perp frame, which is kind of like a plane which we used earlier, except this one gives you a plane along the curve. So the input here is a curve, which is this line here, and we need a parameter to locate at which point on the line we want the plane. So normally we prefer to work in a range on lines between 0 to 1. So the 0 would be the start of the curve and 1 would be the end of the curve. So if we input that here now, you can see that we have a plane at the beginning here, but if I move it, it's barely moving, and that's because in Grasshopper, the definition of the line or the domain of it is the 0 to the length of it. So to fix that, you can just right click on the curve here and press reparameterize it. And then we have a domain from 0 to 1 on which we can create our perp frame. So this is the parameter 1 that I sketched for you. Just call it P1. You can see it here. And again, you can see here, I can't zoom anymore right now, but there's a green plane here and there's a red vector here. So this is the Y direction of that plane, and which is going in the global X direction, and the local Y is going in the global Z direction. So we can deconstruct this plane to get the point which we want to move. So deconstruct plane, I can write a little more because you don't get it up. So select that, input the frame here, and you can see that we get a point. So the next thing then is to move the point, and here you can see that we deconstruct the plane, we get the origin, we get the x-axis, which is the small red line here, we get the y-axis, which is the small green line here, and you can see the vector here, which is a unit vector in the global x direction. So again, we will just use a move component. The point to be moved is the origin here. And the motion, we're going to need a multiplication factor now. The local y-axis, which is the green one, we wanted to go out from the plane, and a factor to multiply. So let's make it a little different. Let's take it as a percentage of the length of the line here. So if you type length, there's a component which calculates the length of the line. You can see now this is 1761. And we will create another multiplication. So like this, sorry, just the first one. And then we will make a slider going from 0, 0, 1 to 0.2 maybe, which is going to give us 20% of the length if it's at the maximum. Okay, so the P2 parameter will be a percentage of the length of the edge that we're modifying. So just input that here. So we have a unit y-axis, which we are multiplying by a length of which it will be translated. So I'm putting it here, and now you can see that I can move it outwards from the edge, and I can choose at which parameter it will be located. So we now have the point that we're interested in. I will just hide this point. And the final thing now is to create a new line or a polyline between these 3 points. So to do that, we need the endpoints component of this line. So you can see that gives us the start point and the end point. If you're not sure which is which, just move this P1 parameter. You know that 0 is the start, 1 is the end. So then you will also find a start and end point here. And this geometry will be the middle point. So I can rename that for simplicity. Just call it middle. So we have a start point, and middle point, and end point. So now we do exactly the same as we did with the lines previously. I just create a point container to keep track of it. We have a start point, hold shift, then the middle point, and then the end point, because the way you input these now will affect how your line looks. So it's important that you put them in the right order. So then we can just search for a polyline curve. We have our vertices here, 3 points connected here. And as you can see now, we have a new polyline which we can modify. So we have created this line here. Now in Grasshopper, it's completely parametric, so we can change the way it looks. So I just keep it like that. And finally, we just want to modify the surface. So instead of just being a rectangle, we want to include this part here as well. So we know that this is the item 1. So we have 4 edges. Just going to keep this simple. Just have to input that there again, there. So of course we can now change what number of lines we want as well. If we want this edge line here, we can just take it from here. But let's keep it here now, and finally we will just connect the 3 lines here plus this new polyline to create a boundary around the surface. So boundary surface component. Again, I use the first edge, the second edge, which is now the polyline here, the third edge, and the fourth edge. There you have the modified surface. Here. And instead of moving this surface, we can just input this. And as you see, we have some sort of parametric building now where we can modify this edge. So did anybody, or no, I won't ask about that. So who finished? If you raise your hand, if you're finished. A couple of you, that's great. I see that we have 20 minutes left. I don't think there is a point in beginning of the next one. We won't get even halfway there. So if there are questions, we can discuss it. If anybody wants to show their Grasshopper file, you can do that. We can help you. And if not, you can try, of course, to play along for the rest of the 20 minutes today. You have everything you need now. You can try to make an edge here, try to make it here, and change parameters and get familiar with the concept of the Grasshopper script there. I think that is a good training for you. And afterwards, I will download another version where you can modify all the edges separately with the NURBS curve here as well, that you can play around with if you want to. So are there any questions?
Okay, so one of you wants to know how to use the vector display. Very good. I will share my screen. Let me see. Screen one, do you see my screen? I hope everybody does. I will just move it to the side and yeah, vector displaying of the vector is very good option to know. So I will start with generally creating a plane. Let it be, let's go for the sets, for the math, for the vector, sorry, and then plane. And we have something, for example, XY plane. Let's zoom to it. We have a plane and origin. And generally the word XY, it's not saying you so much because, or per definition, we know that the red it's X, the green it's Y, but we would like to see it in the Grasshopper. So I will deconstruct this plane. So now I generally can read that x-axis it's 1, 0, 0 according to the global coordinate system. Of course, sometimes when it's rotated, we would like to visualize and see this x-axis. To do that, we have something which is called vector display. We have a vector display and we have also vector display x. But let's start with the classic one. And one thing is anchor. So this is the origin, x-axis it's here. And I will just zoom to it, zoom on the preview to see. And this is my x. You see it here, the arrow. You can right click on it. And here you have an arrow's relative either default either the screen size, so you can make it a little bit bigger or smaller. So this is one thing. If you change to the Y, now you see it's Y, and the Z, it's here. So you can generally say this. So if you, for example, create a series which will introduce you a couple of numbers, and you will create XYZ point based on this. So I will have 10 points now, and I would like to create 10 planes, like the XY planes. I see that generally Z-axis is in this direction. I know that this is kind of the simple, but sometimes it's a good question because generally when you will go into more complicated geometry, it's very important to know which direction it's X, Y, and Z. So when it comes to the EX vector display, then this is a point, this is a vector. I will just turn it off, and you have it a little bit differently made. You can also make a color. To make a color, you just type color, or there is something like a color picker. Yeah, it's here. So you can generally move them like this, and this is picking a color. So now if I would like to have a green or that change it to the blue. So you see my arrows are blue. So a vector display EX needs a point and a vector. And generally that's all. I don't know if I explain it good or not. So raise your hand if you are asking about this and you have your solution. No answer? Should I continue or? Okay. If it's okay, it's okay. Uh, okay, one thing that generally, if you have any questions and you want to work, because now it's like the time for you. We are available for you till 20 minutes after 3, and you can ask questions. You can contact us privately on the chat, so you don't have to make a public question. But in general, we see each other tomorrow at 9 for the next day. So for today, we finished with the official lectures. Is it okay? Yeah. So now it's like your own time to work on the on Rhino and Grasshopper. So see you tomorrow for those who finished the whole model today. Yeah.